So now that we've talked about total cost and total fixed costs and total variable costs, let's dive into the average costs. We're going to talk about average total cost, average variable cost, and then average fixed cost as well. So the average cost, what is the average cost? It's the measuring cost on a per unit of output. So whenever we were talking about the total cost, we were looking at everything from a total standpoint. What was total fixed? What was total cost? And what was total variable cost? Without really looking at it on a per output basis. Whenever we talk about average cost, we're gonna put it on a per output basis. How much is this costing me per unit of output? How much is this costing me per cow? How much is this land costing me per cow? How much is this tractor costing me per acre, or not, maybe not per acre, but per bushel, or something of that nature? We're going to put everything on a per output basis. So we're actually going to be looking at the level of cost associated with a level of output on that per output basis. So how do we calculate the totals? If it's on a per unit of output, how do we calculate that? How do we get to that? Well, it's very simple. We just divide it all by output. So if we're going to calculate average total cost, ATC, notice that I like my abbreviations here as well, we're going to take total cost, or TC, divided by output. To calculate average variable cost, AVC, we're going to take total variable cost divided by output. And if we want to calculate average fixed cost, or AFC, I've got the wrong letter in there, but that should be an F right there. If we're going to calculate AFC, we're going to take total fixed cost divided by output. So basically what we're going to do is we're going to take these totals, total fixed cost, total variable cost, total fixed cost, and simply divide it by output. And that's going to give us our averages. So what does that do? We're going to go ahead and graph that as well and look at these different averages graphed. So again, whenever we graph it, the things to pay attention to is what is your horizontal and vertical axis on your graph. Again, your horizontal axis is output. Your vertical axis is dollars again. It was the same way whenever we were talking about the totals, but now as we get into the averages, it's the same thing. Dollars on the vertical, output on the horizontal axis. So let's look into each one of these graphs. So first off, let's dive into the average fixed cost. This average fixed cost is this blue line right here, and we notice that it falls, and then it continues to fall. And it just keeps decreasing. So our average fixed cost curve actually continuously is falling. It's continuously decreasing. Well, why is that? Well, it's the aspect that the cost is, and I got a spelling error right there, is spread out. So the constant cost is actually spread out over more units of output. It's known as spreading the overhead. So let's think about this. As we use more units of labor up until we get to the 62 hours mark, and it's at that point in time that we actually hit that peak in our production function. And as long as we use more labor, our output is going to continuously increase. But what's happening to our fixed costs? Our fixed costs don't change. So guess what? If we take our total fixed cost divided by our output and we find our average fixed cost, our average fixed cost is going to continuously decrease. It's going to continuously fall. Why? Because we are spreading that fixed cost out over more units of output. That is a phenomenon known as spreading the overhead. We're going to spread the fixed cost out over more over more units of output and actually lower our fixed cost per unit of output. On a per unit of output, our fixed cost is continuously decreasing. Even though total fixed cost doesn't decrease, our fixed cost per output is decreasing simply because we're producing more. Now, our average variable cost curve. What's going on with it? Well, it decreases to a point and then increases as output increases. So let's look at our total or average variable cost curve, which is this red line right here. We see that it's falling. And then it kind of hits a minimum, and then it begins to go back up. Well, why is that? why would our average variable cost curve decrease up into a point and then begin to increase? Well, that phenomenon actually has to deal with the aspect of that production function. So if you remember back to that production function, and as we were talking about the production function, we said that, those first bit of inputs, they provide a large amount of output. And then as we use more inputs, the efficacy, I guess you could say, of those inputs begins to decrease. As we use more inputs, our output will continuously increase, but not at the same rate. It actually begins to increase at a decreasing rate. If you remember that phenomenon, what it transpires over here into this average variable cost curve, this average variable cost curve shows us that over time, our output, we don't get as much bang for our buck in terms of our output and things like that. And we're actually going to compare this average variable cost curve to the average physical product curve here in a couple slides. And it's actually going to kind of clarify that project or that aspect a little bit more. But we need to know that the average variable cost curve, it actually decreases. It goes down, it hits this minimum, and then begins to increase as well. So then let's dive into the average total cost curve. So this average total cost curve, we figure out our average total cost curve by taking the total cost divided by output. Well, how do we find total cost? Well, remember, total cost was the summation of average or total variable cost and total fixed cost. So this average variable cost this average total cost curve by default includes average variable cost and average fixed cost. So we know that this average total cost curve is a component of average variable and average fixed. Well, we know that average fixed continuously decreases, but average variable will decrease to a point and then begin to increase. So because of that, whenever we add both of them together, we actually see that this average total cost curve will decrease to a certain point and then increases as output increases as well. So we notice that the average total cost curve kind of does a little bit of the same thing of what the average variable cost curve, but it doesn't quite look exactly the same. Well, it's not going to look the same because it's also factoring in this average fixed cost curve that is continuously decreasing. And in the next couple of slides, we're going to dive into a little bit more about what that means. What is that minimum point on that average total cost curve? What does that mean? What does that minimum point on the average variable cost curve mean? And what does it mean that the aspect that this average fixed cost curve continuously decreases? We're going to dive into that in a little bit. But the key things to remember out of this slide is how do you calculate these three components? And how do you calculate average total cost? Well, we're going to take total cost divided by output. How do you calculate average variable? We're going to take total variable divided by output. How do we calculate average fixed? We're going to take total fixed divided by output. And what I would encourage you to do is take a couple of minutes and look at the slide and actually try to see if you can replicate these numbers and use the formulas. Use this formula, this formula right here to see if you can come up with this table or this column. Use this formula right here to come up with that column. And then use this one right here to come up with this column.